Design and simulation of a blender in CFD by group number 12. Chemical industry deagitation is very important. There are two types, axial and radial, which differ in the way they impel the fluid. Some important variables in this process are the power related by the power number and the Reynolds number that indicates the regime under which the movement is generated. Materials and methods dimension on a screen the geometry of the blender modeled. Chosen models. The selected models for the simulation were chosen in order to fit the real phenomena happening inside the blender. These models predict the mean values of some properties, such as the fluctuation of the turbulence, the kinetical energy of the fluid, and the rate of dissipation in order to give an approximated solution to some equations in all the mesh. Some, such as exact wall distance or transitional boundary distance, are especially for the boundary zone. Mesh. On screen, the region selected for the mesh. The parameters selected for the mesh are presented in the table. Simulations. In a screen, the process followed to obtain the results. Although both curves have the same behavior, the results obtained are different. For laminar flows, Reynolds number around 1 and 10, both curves follow the same pattern, where the power number decreases with a constant slope. As the flow became in a transitional flow, the theoretical curve continued falling, but with a different slope. By contrast, the simulated curve keeps falling with the same slope. Finally, both curves stop pumping after the Reynolds number takes a value of 100 and then continues constant during the range that corresponds to a turbulent flow. Velocity. A low speed is maintained along the length of the vessel, while the speed increases in the blades and around them, especially at their ends. Interface, weather, air. Simulated. Experimental. Interface, honey, air. Simulated. Experimental. Comparison. A vortex in a fluid is created in the middle of the blades because the water has a low density and the vortex is easily produced. In both videos, axial flow agitation is generated. Since honey has a viscosity and density greater than water, it's difficult to generate the vortex at the same RPM. Conclusions. The behavior of the results obtained for the simulation of the blender agree with the reported. It has found that the fluid rotates axially. With respect to the multiphase simulation, in the case of water with air, a vortex is formed near to the blades, a situation that does not occur with air and honey.